Okay, so in this example here, we're going to be talking about how to solve exponential equations, meaning how do you solve an equation when you have a variable in the exponent value. So in order to do these problems here, you have to know the following, and that is the power property of a logarithm. So if you have log and then base of x and then all to the power of n, based on the power property of a logarithm, you can then take this n, this exponent, and bring it down to the front, meaning I can rewrite it as n and then log base b of x. And we're going to use that to our advantage in these examples here, and I'll show you how it's going to work out. So let's go ahead and get rid of all this here. And your first step when you're solving these exponential equations is that you want to isolate the base and the exponent, meaning I want to isolate this part right here. Okay, that's my first step. And then from there, we'll go ahead and solve for x. So to do that, I first have to add 7 on both sides. When I do that, I get 5 to the x power equal to, well, 9 plus 7 will give me 16. Okay, and then from here, I have to go ahead and bring down my variable right here. In order to do that, I have to take a logarithm on both sides. Remember, what I do to one side of the equation, I have to do to the other, so I have to balance it out. So taking a log on both sides, that will give me log and then of 5 to the x power equal to log 16. And now we can use the power property, meaning I can bring this variable of x down to the front, and I can rewrite it as x log of 5 equal to log of 16. And from here, you're going to solve for x. You're going to divide both sides by log of 5, and you're going to get x is equal to log 16 all over log 5. Okay? And so when you divide that in your calculator, you are going to get an irrational number. So if you want to maintain accuracy, you can actually leave it like this here if you'd like. But if you do plug it into your calculator and you just round it to like the nearest hundredth, you're going to get the following. You'll end up getting x is about 1.72. Okay? So let's go ahead and try another example. So here's our next example. And again, our first step, we have to isolate the base in the exponent, meaning I have to isolate this part here. I have to get rid of 200, meaning I'm going to have to divide it out because I'm multiplying here. So you're going to divide both sides by 200. And when you do that, right, I'll divide here by 200 and it will cancel out. And dividing here by 200, well, the zeros will cancel and I'm left with a half. So I have a half is equal to 0.75 all to the x power. And then from here, we're going to take a log on both sides. So I get log of a half equal to, and I'm going to bring down the variable right now. So x and then log of 0.75. Okay. And then from here, you're simply going to divide both sides by log of 0.75. So you're going to get x is equal to log of a half divided by log 0.75. And again, to maintain accuracy, you could leave it like this here, or you could go ahead and plug it into your graphing calculator. If you do that, you will get the following. You end up getting x is about 2.41. Again, if you round to the nearest hundredth, and that will be done right here. Okay. So again, two different ways you can write it. If you want to go ahead and round it, go ahead and plug that into your graphing calculator. But if you want to maintain accuracy, what we have right here is good. All right. So let's go ahead and try one more example. So here's our last example. And again, we want to isolate the base in the exponent. And I do have that isolated right here. So we can actually take the logarithm right now. So I'm going to do log of 400 equal to, I'm going to bring down my entire exponent. That is going to be x plus 1. And then times log, and then we have of 0.65. And so from here, remember, we're trying to solve for x, and I have multiplication here and here. We're going to divide by log 0.65. So I'm going to get log of 400 divided by log of 0.65 equal to x plus 1. And your last step here, if you want to maintain accuracy, just subtract 1. So you're going to get x is equal to log of 400 divided by log of 0.65 and then minus 1. And there it is. You can leave it like this here. Or you could go ahead and plug it into your graphing calculator. If you do that, you will get the following. You end up getting x is about 14.91, and it will be negative. So negative 14.91, and there it is if you round it. Okay, so that is going to do it. That is how you solve an equation if you have a variable in the exponent value. It's pretty straightforward. You're simply going to be taking a logarithm in order to get around that. But before you take that logarithm, remember you do have to isolate the exponential, meaning you have to isolate the base in the exponent, and then you can go ahead and take the logarithm. All right, so that's going to do it. I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.